Dr. Tramontano, the medical director at the NeuroCognitive and Behavioral Institute here in New Jersey. And today's presentation is on a pretty common problem that we see across a number of different patients at our institute, and it has to do with regulation. And that includes regulating all kinds of impulses, behaviors, emotions, as well as sensory regulation for patients who have hypersensory reactions to different stimuli. So I think this presentation will help you understand why these disorders or symptoms are so common, and hopefully provide a little insight into how they can be diagnosed and, more importantly, treated. So why are emotional, behavioral, and sensory regulation difficulties so common, particularly in patients with various neuropsychiatric disorders? So one plausible explanation has to do with connectivity. For example, the weaker points in structures are generally where two separate pieces are connected. So if you think of damage, let's say on a house from a hurricane, typically it's where the roof is connected to the house. Often the roof is blown off during the hurricane. Well, in neuroanatomical structures, it's where the old brain meets the new brain, and that's a weak point. So if we look at the current slide, and I'll highlight just some simple anatomical structures, so your spine coming up the brainstem and the pons, and at the top of the brainstem is the limbic system. And this whole structure represents your autonomic nervous system. And then surrounding this, over the limbic system in the brainstem, is the cortex. So as I mentioned, the connectivity in and of itself marks this as a vulnerability, particularly in a variety of different types of disorders, from neurodevelopmental based disorders like attention deficit hyperactivity disorder to neurodegenerative diseases such as the frontal temporal diseases or frontal temporal dementias, as well as acquired and traumatic brain injury. The weak points get overexposed in these disorders. So you may be asking, why do we even still have an old brain? So throughout evolution, the way the brain developed, or the central nervous system developed, it developed in layers, one on top of the other. So the autonomic nervous system at one point was our only nervous system. So it was responsible for being our nervous system and doing all the wonderful things that nervous systems do to keep us alive. And it still houses some very critical features, such as our memory center, which is the hippocampal formation, and our fear button. Sometimes the amygdala is referred to that as a fear button. It's responsible for that fight, flight, freeze type of response. And this whole region is often referred to as the emotional brain, or in neuroanatomical terms, the limbic system. And it's connected to the new brain through a pathway. And this part of the cortex, the orbital frontal cortex, one of its primary responsibilities is to govern or to regulate what is occurring in the limbic system. Okay, so this pathway in purple, the Unsenate Pathway, is the primary pathway that the limbic system is regulated by the orbital frontal cortex. So pathology or impairment, either to the hubs of this pathway or to the connectivity pathways themselves, are what generally is responsible for regulation disorders. So for example, patients with impulse control disorders or hypersensitivities, such as what you find in autism, for example, or ADHD, compulsive behaviors. All of these various behavioral disorders that can present with some form of dysregulation, in many of them, this pathway is responsible to some degree, in many cases to a very significant degree, to the problem of regulating that behavior, that impulse, or that emotion. And here is another example from an fMRI image of that unsenate pathway going from the orbitofrontal region to the limbic system. So what this slide is showing is that there are several neurotransmitter systems on the slide here, and the dopaminergic pathways or systems is the neurotransmitter system that has the most projections in the orbitofrontal cortex, whereas some of the other neurotransmitter systems, such as the serotonin or serotonergic system, has less projections to the orbitofrontal cortex, and likewise with the acetylcholine tracks, they're a little bit higher, but can sometimes activate some of the activity in that orbitofrontal region. And I should mention there are also secondary regulatory pathways up higher in the supplemental motor area, up in this general region where the white arrow is being circled, which can also allow for some secondary regulatory control. So the reason that this slide is there is it kind of provides an explanation for when there is underactivity or slowing in the orbitofrontal cortex or in the connectivity from that region back to the limbic system. This is where you can use dopaminergic type of medications such as methylphenidate in an attempt to stimulate or activate that hypoactivation or that sluggish area with the goal of improving impulse control or regulatory control. This also explains why dopaminergic types of medication are more effective generally in helping improve inhibitory control as opposed to serotonergic or acetylcholine types of medications, which can provide some benefit, but because the projections are not as strong in those areas, you may be getting benefit from those medications from either its secondary effects on secondary regulators or some of its lower inferior prefrontal activation. But in general, serotonergic, acetylcholine medications are not as effective as, for example, a stimulant-based medication for improving impulse control. But there's an important caveat that I want to mention again, that it really depends on what type of pathology is underlying the regulation problem. So for example, if there's hyperactivation in this pathway, stimulating it is generally not going to be of any value. In fact, it may actually worsen the situation. And that's where brain imaging can be very helpful in determining and helping to figure out if the emotional or behavioral regulation problem is secondary to under or overactivation in this pathway. And this is just another schematic, again, showing where the dopaminergic projections traverse more through the orbitofrontal cortex, as well as up in the middle and higher portions of the prefrontal cortex, where you have your secondary regulators, more so than the cholinergic system. Okay, another way to manipulate the physiological activity in certain pathways without medication is with high-density neuromodulation. And that's what this slide is showing, showing different neurophysiological cuts of areas of the brain using non-invasive, meaning from outside of the head, neuromodulation techniques to activate or deactivate select structures or networks in the cortex and manipulate or modulate those networks in a direction to, in this case, improve regulation. So more focal and non-invasive interventions like neuromodulation are being developed and have been over the past 25 to 30 years now, and they're getting better and better, and slowly these devices are being approved. So for example, a few years back there was a neuromodulation device approved, the Attendor is one of them, by the FDA for treating the impulse control difficulties found often in children who have ADHD, as it generally directs at that left orbital frontal cortex with the goal of activating that pathway should the traffic be moving too slowly or if the hub is too sluggish and it's not allowing the child enough activation in that area to regulate those impulses. And it also works on the right frontal parietal cortex, which is a major branch of the attention network. So this is a kind of an exciting area, and a lot of research going on in the field of invasive as well as non-invasive neuromodulation techniques for lots of different disorders. So that's about all for today. So I hope this information was helpful. In other presentations, I've spoken in more detail how we evaluate and treat behavioral and emotional dysregulation disorders. So if you're looking for some additional information, I recommend checking those presentations out. If we could be of any more help to you, please don't hesitate to contact us. And thanks again for your time and attention.